Hello, class. So we are in section 1.5 right now, which is about equations. All right. And so this is really the first big section, so hopefully this video doesn't take too long. But I'd like to start off by asking you hypothetically a question. All right. Is this an equation? All right. So if you want to pause the video, you could pause, ponder on this. All right. Hopefully you've paused and thought about this for more than like a second. All right, the answer is no. This is not an equation. That is an expression, right? That was the title of last section. All right. So what is an equation? Okay. An equation is basically a thing with an equal sign. All right. You need an equal sign to be an equation. If it's just kind of some math, then it's an expression. Okay. And so a thing we can do with equations is we can solve them, right? We solve equations, but we simplify expressions, okay? So that's like kind of like some big philosophical things I'm saying right now. But like, so here's an example. 2x plus 1 equals 4. Okay. Because this is an equation, we can do things like with equal signs, right? So like for example, I can subtract 1 to both sides, right? If it's like just 2x plus 1, there's like no other side. Like, right, where am I going to subtract the 1, right? So we have like lots more freedom to do things when we have equations, okay? So this is going to be 2x equals 3. And then, right, I can divide both sides by 2. And we're going to get x equals 3 over 2. And ta-da, that's the answer. Okay? So these things, these like equal arrow things, they're technically just arrows, like if you wanted to connect them, right? That's fine. That is an implication symbol, okay? Or it means imply. So it's what makes you go from one equation to the next equation to the next equation, okay? Because you shouldn't really write equal signs here. Okay, you should use arrows to be like, oh, this means this, then it means that, okay? All right, so the first kind of equations we're going to talk about is stuff we kind of should know, this should be review, is a linear equation, okay? So the standard form is ax plus b equals 0, okay? This is what we call standard form. Okay? Um, and we can solve, okay? So like here, example, this is a linear equation. I solved it. All right. I'm gonna escalate it, make it a little more complicated. Okay, so one of the differences between being in Math 126 and 124 is that in Math 126, we expect you to know how to deal with fractions. Okay, so here's an equation, linear equation, okay? What makes it linear is that there's only x's to power 1s, okay? So, how do we deal with this? Either one, you can just actually deal with the fractions, um, or two is you can multiply by a big number to cancel all the fractions, specifically by the common denominator, okay? So I'm gonna multiply both sides by 20, okay? So what happens? So when I distribute 20 divided by 4 is 5, so I get 7 times 5, 35x. 20 divided by 4, 20 divided by 5 is 4, so you get that. This will get you 30x, and this is going to get you 40. Okay, so ta-da, the fractions are gone, and now I can just, deal with this like normal. Okay, I'm going to subtract 30x from both sides, and I am also going to add 4 to both sides. Okay, so what happens? Well, so 35 minus 30 is 5x. This cancels, and then that cancels. And negative 40 plus 4, that's going to be negative 36. Then I'm going to divide both sides by 5. And you're actually just stuck like that. So, pi symbols. You get x equals negative 36 over 5. Ta-da! All right, so not so hard. Hopefully this is just review, right? Either you took 96 and have had to do this for a while, or you took an ALEKS test and you have qualified to know how to do these. Okay, so I'm going to assume you know how to do these. Next thing is you need to be able to solve for letters, okay? So you need to be able to do like actual kind of meaningless algebra, I guess. So solve for one variable in a formula. All right, so here's a formula. It's actually very famous, but let's not care. Okay, little m capital M, okay, r squared. Okay, so let's pretend the question is solve for little m. Okay, so if you want to solve for little m, that means you need to get the little m by itself on one side of the equal sign and everything else on the other. Okay, so I'm going to divide by capital G. So f over g equals m r squared. Then I'm going to multiply both sides by r squared. Right? So I have r squared f over g equals m. And then lastly, I'm going to divide both sides by capital M. And you get the answer. Little m will equal r squared f over capital M G. Okay. And so I could pick any letter, right? I could have said solve for R. I could have said solve for G, right? It really doesn't matter, okay? So you should be comfortable just moving letters around equal signs is what I mean by doing this, okay? So here, I'm going to have a different equation that is also meaningful, but let's not talk about it. A equals 2ly plus 2wh plus 2lh. Okay. And I want you to solve for L. Okay. So what you want to do when solving for letters, right, is really you want to get it by itself. Okay, so step one is you notice this has an L, this has an L. This one doesn't. So I'm going to move it to the other side. Okay, so A minus 2WH equals 2LW plus 2LH. Okay. Now, next thing you want to do is you want to get 1L, right? Here I have 2, but now that everything on the right-hand side has an L, I can actually factor it out. Okay, so you're going to get A minus 2WH, 2W plus 2HL. Okay, and then now you're basically done because you just want to get rid of this thing. So that'll cancel, and then you get the final answer. Plus. The final answer is L equals A minus 2WH over 2W plus 2H. Okay. And right, same thing. I could have just said, what's W? Right, what's H? All right, so again, this is just, are you comfortable with moving things around equal signs? All right, because you should be. But that's it for kind of linear equations. Okay, these have all been linear because we haven't had to do like some fancy square square root kind of stuff, okay? Moving on to the real kind of meat of this section is quadratic equations. So again, this should be a review. Hopefully you know, okay? A quadratic equation is anything that looks like this. Ax squared plus bx plus c equals 0, okay? And again, this is a quadratic equation in standard form. All right. No, here a can't be 0, because if a is 0, then it's actually just a line again, okay? So to be a quadratic equation, it needs to be like this with the squared. Okay, the squared is what makes it a quadratic, okay? So, we should also be able to solve things like this. Okay, so if you have x squared plus 5x equals 24, what you should do is you need a 0, okay, like this. You need to get a 0. So I'm actually going to subtract 24 to both sides, okay? And we're here. Then we have options, okay? So here, I'm going to factor x minus 3, x plus 8, okay? And then from here, by the zero product property, okay? So I'm going to show us like the middle steps. The middle steps is, right, you technically do these. You set each of these equal to 0 and solve the tiny ones. And that's how you get x equals 3 comma negative 8 as the final answer. Okay. But I'm sure most of you kind of just memorized it's the opposite of whatever is in the parenthesis. Okay. But that's why. So I kind of want to talk about how we solve these things. Okay. So there should be like a flow chart or a way of how you solve these. Okay. So number one is that it's easy. Okay, and we haven't even seen one. I'll show you an example of easy next. Okay, but that should be the first way you solve these things. The second way you solve them is by factoring. Okay. The third and last way is you can pick between the quadratic formula, which I will introduce, or complete the square. And that's kind of like the last resort. Okay. So you should first kind of go in this order. Okay. All right, so here's an example of something that's easy. Okay. An example of easy is this. All right, because here, it really doesn't matter that it's quadratic. Okay, you could just like move the thing to the other side, and then square root both sides. And then remember though, big deal, huge deal, very important. Whenever you square root both sides, you get a plus minus. Okay. This also you can factor though, right? This is a difference of squares specifically. So that's kind of why it's x squared. Okay. And then you see that you get the same answers, right? X equals plus square root 5 minus square root 5. Okay. Now, so this is easy. You just move and then get rid of it, right? A more complicated looking version of an easy is this. Okay, this is interesting. All right. Because here, you kind of can do the same thing, okay? You don't want to FOIL. You want to move the 2 over, and then you're going to square root both sides. Okay, and then you're just going to get x minus 4 equals plus or minus root 2, and then x equals 4 plus or minus root 2. And that's your answer. Okay. So this is basically the end part of completing the square. Okay. So I will now show you how to complete the square, okay, because sometimes things don't factor. Like this This doesn't factor, right? You could not get this answer trying to factor it, okay? You have to complete the square or quadratic formula. So here is this thing, okay? All right, so step one is you would try and factor this, okay? But after about like a minute of thinking or something, you either realize it doesn't factor or you just kind of give up, okay? So how you complete the square is, remember, right, this is like ax plus b equals plus c equals 0, okay? So we want to look at the b, okay? B is -8 here, okay? So then you want to do b divided by 2, which is -4, okay? This is important. And then you're going to square it. So that's 16, okay? 16 is what we're going to add to both sides of the equal sign, okay? So I'm going to write it down like this. X squared minus 8x plus 16 plus 13 equals 16. Okay? And the reason we do that is because this right here magically factors into x minus 4 squared. Okay? And it's always going to factor into just like x minus something squared. Specifically, it always factors into this thing, whatever b over 2 is. Okay? So if you're ever confused about what goes here, just look at this middle step. It's -4. Okay, that's what goes there. Okay? And then the other two you just kind of leave them. Okay? And now that you've done that, this is this thing. Right? So I'm going to subtract 13 to both sides. X minus 4 squared equals 3. Then square root x minus 4 equals plus or minus square root 3. X equals 4 plus or minus square root 3. And ta-da, there's your answer, okay? Back when we like if you had like real online homework with like WebAssembly and stuff, I think they would force you to separate your answers like this. I'm okay with either. Right? If you want to do this with the plus minus or this separated them, either is fine. Okay. But yeah, so this is completing the square. It's really just memorizing these 3 steps. Okay. Just memorize how to do these 3 steps and then magic happens. Okay. And so one benefit of completing the square is that completing the square, all right, automatically fully simplifies your answer. Okay. So whenever you complete the square, the answer you get is automatically fully simplified. Okay, so if you had to simplify your answers, completing the square may be ideal. Okay. All right, now solving this thing. Okay, we're gonna do a slightly harder complete the square. Okay, and so why this is slightly harder is because of the 3. Okay. So, this 3 messes a lot of things up. Okay. Why? Well, because, so if I did the same thing, right, b equals -12, right, that's just wrong. Okay. The reason is complicated and I'm not going to go into it, but what you need to do is you need to factor out the 3. Okay. So I'm actually going to move the 5 over because the 5 is being annoying because it doesn't divide by 3 nicely. Okay. And then I'm going to factor out a 3. So 3 x squared minus 4x. Negative 5. Okay. And now I can do the complete the square like normal. Okay. So b is actually negative 4. So b over 2 is negative 2. So b over 2 squared is 4. Okay. So here, okay, again, though, you need to be careful because this 3 is being annoying. All right. Instead of just adding 4 to both sides of the equal sign, because that really wouldn't work, I would actually need to add 12. What you're gonna do is you're gonna add and subtract 4 inside this parenthesis. Okay, so plus 4 minus 4. All right, and then that becomes 3x minus 2 squared minus 4 equals negative 5. Okay. And so this is a big deal, okay? Because these 4s are technically 12s because of this 3, right? Because now I have to distribute the 3, and you see that I'm going to get 3x minus 2 squared minus 12, okay? So that's why I couldn't just put plus 4 over here, all right? Is because it's not really a 4, it's a 12. Okay. But now I'm done, right? So 3x minus 2 squared. Add 12 to both sides. So that will be 7. Okay. And then divide by 3. So x minus 2 squared 7 over 3. And then square root, and you get the answer. So x minus 2 plus or minus square root 7 over 3. X equals 2 plus minus 7 over 3. Okay. And ta-da, there's your answer. Okay. I'm just gonna move some stuff over. All right. So this is the harder version of completing the squares when you don't have a 1 here, because you got to be a little careful with how you do this, okay? But this is very important, okay? This will come back because we're going to need to do a lot of things with quadratic equations. So I would highly encourage you to actually learn how to complete the square when there's a number in front, okay? It's very, very important, okay? So completing the square, awesome. Okay. If any of you want to try something interesting, is I would tell you to complete the square with this thing. Okay. Because if you actually complete the square with this, what happens, okay, is you're gonna get x equals this thing. Okay. And that thing has a very famous name. It is called the quadratic formula. Okay. So the other way to get answers from a quadratic equation is just memorize this formula and plug into it. Okay? So let's do that. Example. 3x squared minus 5x plus 1 equals 0. All right. Actually, I'm gonna make this minus sign, but whatever. Okay. So the answer, x equals, and then just plug in. So, right, this is b, this is a, that is c. So negative 5 plus or minus the square root of negative 5 squared minus 4 times 3 times -1, all divided by 2 times 3. And so the cool thing with the quadratic formula is that this is the answer. Like, you get the answer right away. The bad thing is you have to simplify. Like, the whole problem is really simplifying. So, right, -5 is 5. That's 25 plus 12. Okay, all over 6. And then you get 5 plus or minus the square root of 37 over 6. And 37, I'm pretty sure is prime, so we're stuck. So this is the answer. Okay. All right. So here's another example, okay, of completing the square. Example. Okay. So let's just, plug in. So -12 plus or minus the square root of 12 squared, which is 144, minus 4ac, which I actually don't know off the top of my head, so I'm going to write that down. And then divided by 2a, so 2 times 4 is 8, okay? So -12 plus or minus the square root 8. Okay, so 4 times 4 is 16. 16 times 9 is also 144. Okay, so interesting. So plus minus 0. So -12 divided by 8. So -3 over 2. Okay. So some of you might be confused. Some of you might already know what we're doing here. This is a very specific example to show you guys. Just because now you know the quadratic formula does not mean you should forget this philosophy of like easy factor. Then you do that, right? Because if some of you just stared at this for a little bit, all right, you will see that this actually factors into 2x plus 3 squared. Okay, so this is the answer, -3 over 2. It just has multiplicity 2, which just means it's like a 0 twice. Okay, so don't get a little eager with the factoring or the quadratic formula. Okay, always check if something factors. All right, and then here I just want to show you like a cool example. This is a professional tip. Okay, pro tip, as the kids like to say. All right, when you're doing the quadratic formula, right, we have to do like a lot of simplifying, which is not cool. All right, so a pro tip is if b is even, okay, just divide everything by 2. So like, look at what happens. You're gonna get 1/2 plus x minus 5 over 2 equals 0. Okay, now some of you are definitely like, what are you doing? This looks way worse. And that's understandable. It does look way worse. But look at what happens when you use the quadratic formula now. So you're going to get negative b, which is 1, plus or minus the square root of b squared, which is now just 1, okay, minus 4ac. But like, look at what happens. The 4 cancels out with that, so you actually just get like a 5, okay? And then divided by 2a, but a is 1/2, so that also just cancels, and you get 1 plus 5, which equals -1 plus or minus the square root of 6. And ta-da, that's the fully simplified answer, okay? So if you wanted to do the quadratic formula here, you would get something a little bit more complicated that you'd have to simplify at the end, okay? So this is just a cool tip that no one will probably ever teach you again, okay? But if the middle is even, then highly recommended that you do this. All right, it looks cool, and it simplifies stuff for you, okay? All right, and so now I'm going to talk about something that's really not that important. All right, but it could be a test question. Some people care. All right, it's called the discriminant, okay? And the discriminant is equal to b squared minus 4ac, which that should look familiar because it's the inside stuff in the quadratic formula, right? B squared minus 4ac, okay? So the discriminant tells us things about the answer, okay? So, for instance, if the discriminant is equal to 0, then the equation, all right, has one real solution with multiplicity 2. All right, and we saw that right here. The discriminant was 0, right? And what happened? We only got one answer. Okay. If the discriminant is positive, okay, then the equation has 2 real solutions. And like this is what normally happens, right? That's the plus minus, right? Here the discriminant is 6, and we got 2 answers. Here the discriminant is 36, and we got 2 answers, okay? So this is what normally happens. Now, if the discriminant is negative, okay, then the equation has 2 complex solutions, okay? And so we don't know what that means yet, but I'm just gonna kind of crash course you on complex numbers before we get to that section. Okay, so here's the example. Okay, this equation. Okay, I'm gonna stick it in the quadratic formula. I should actually, I'm gonna just do the cool thing. I'm gonna divide everything by 2 because I just told you guys that's a cool thing to do. Okay, and then I'm gonna stick it in the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac, so 4ac, so that's actually 2, okay? All over 2a, which is 1. So you're gonna get this. Right, which this is bad, okay? That's equal to I, okay, plus or minus I. All right, so this I has the property where I squared is -1, okay? And that's what complex numbers are, okay? We'll learn about them later, but that's what that means. If the discriminant is negative, it means this happens, okay? Which for us right now is bad, okay? So what you would do if this was like on a test or something is as soon as you get here, you would just be like, no real solution, okay? This has no real solution. It has complex solutions. It has these ones, okay? All right. Okay. So moving on, we're kind of done with the 2 fundamental equations, okay? Quadratics, right? Quadratics and linear. Okay, now we're going to do some other things that you need to know how to solve. Okay, so one of the things you definitely need to know how to solve are are rational equations, okay? Okay, so rational equations, how do you solve these? Okay, I actually solve these much differently than like textbooks like to solve them. Okay, so you can choose to copy my style or not. Okay, but rational equations. So rational equations are like quadratics or linears, hopefully. It's just at the very start you need to be careful about the domain, and that's why we talked about domain in the previous section. Okay, so right at the start you should stare at this equation and be like, wait, okay, x should not be 0 because that would be a problem, and it should also not be -2. Okay, so right at the start you need to say this, okay, preferably. Okay, because if what happens when you get to the very end, that you're like, oh, x equals 0, then you have to remember that, like, wait, that's not good, never mind. Okay, so that's why we say this at the start. Now, what I would like to do, or what I do, okay, is I like to get rid of the fractions as soon as possible. Okay, so I'm going to multiply both sides by the denominator of both of the fractions. Okay, so what happens is I'm going to distribute, right? And I'm going to show like a little too much work, right? You guys would not need to show this, but I just want to show you what happens. Okay, x plus 2, 2x, x plus 10. All right, so what happens when you multiply by this thing, or the denominators, is right, this cancels and that cancels. So you actually just get this. Okay? And now there's no more fractions, right? Now this is just a quadratic equation. Okay? So you would just solve this like any other quadratic equation. Okay? So I'm gonna, start to solve it. Okay, so I'm gonna distribute the 3, and I'm gonna, distribute here. So 2x squared plus 4x, okay? I'm gonna move everything to the right. So 0 equals 2x squared. Okay. That is 8, right? That's 8x. So 4x minus 8x is -4x. And then move the 6 over, so -6. All right, so we're here. Actually, I have a really cool thing, right? You can divide everything by 2, and that makes life way easier, okay? Because now, it factors. X minus 3, x plus 1. So the answers are x equals -1 and 3. And before you box this in, you should scroll back up and be like, wait, is that okay? You check, yes, it's okay. So then you box it. And you're like, ta-da, there's the answer. Okay? So this is how you solve, well, at least this is how I solve rational equations. Okay? We're gonna do more of these in the later section, so it's not like super important that you freak out about these, but you should know how to solve them by now, hopefully. Hopefully this whole section really is review. All right. Now the second thing is roots, okay, or radical equations. All right, and so this is really the opposite of a quadratic equation. Okay, so if I have like 3x equals the square root of 2x plus 1, okay, so this is just one example. I'm going to do 2 of these because there's like an easy version and a hard version. So this is the easy version. All right. Right? You can think of algebra as just kind of undoing stuff. Okay? So what we're going to do is we're going to square both sides. Okay? When you have a square root by itself on one side of an equal sign, okay, you can square both sides, and we're going to get 9x squared, okay, because remember, you got to distribute, equals, and then write the square root and the square, they kind of cancel, and you get 2x plus 1. And then you see 9x squared minus 2x minus 1 equals 0. I'm going to do my cool quadratic formula thing. X minus 1/2. Stick this in there. So x equals negative b plus or minus square root 1 plus 9 all over 2a, which is 9. So 1 plus or minus square root 10 over 9. Ta-da. Okay, so this is how you do a root equation. Okay, but it can get worse. Okay, so what I mean is when you don't just have a square root by itself. Okay, so I'm gonna do just like a a slightly more complicated one. Okay, so here, all right, you can just believe me, or you can try it by yourself, but you do not, all right, do not just want to square both sides automatically here, okay? Because remember, you can't split across a plus, right? You would have to FOIL, and that's just going to be bad, okay? So it's really important that you move the 2 to the other side, okay? And you get the square root completely by itself on one side of the equal sign, okay? Very important. As soon as you do that, then you can square, okay? But then you're like, wait, now I have to square this, and that's annoying, which it is, okay? X squared minus 4x plus 4, okay? Hopefully you memorized the squaring formula by now, okay? If you haven't, you can FOIL it, but you get this. And then x plus 1, and then you just solve this like any other quadratic equation, okay? So, plus 3. Wait, does this factor? No, it definitely doesn't. Yeah, there's no way, okay. So yeah, okay. Let me complete the square, actually, because I've been quadratic formulating a lot, okay? So b equals -5, b over 2 equals -5 over 2, b squared is 25 over 4. A little nasty. So you're gonna add that to both sides. Okay, minus 5x plus 25 over 4 plus 3, 25 over 4. This factors into x minus this thing, okay? Oh, wait. Oh, no, I'm fine. Okay, yeah. And then I'm going to move the 3 over. Okay, so 25 minus 3. But instead of 3, I'm going to do 12 over 4. No, just, yeah, 12 over 4, which is also known as 3. Okay, and then I'm going to get the answer. So x minus 5 over 2. Yeah, let me simplify this. So this is 13 over 4. Okay, so plus or minus square root 13 over 4, which is equal to 5 over 2 plus or minus, and then you can split the square root, and the square root of 4 is 2. So you can actually get the kind of pretty answer, this. Okay, but you wouldn't have to do that. Okay, if you wanted to leave it like If you did this and you got 5 over 2 plus minus square root 13 over 4, that's okay. You don't have to simplify it to this thing, okay? But yeah, ta-da. Okay, so it's really important when doing root equations that you get the square root by itself on one side. Okay, very required. Okay, if you don't, it's gonna foil and it's just gonna be bad news. Okay, all right. Now, the last thing that we have to do, okay, is really your textbook likes to pretend like this is not something I need to talk about, and that you should just automatically know how to do this, but I know better. So it's reducible to quadratic, okay? So the idea here is that you know how to solve a quadratic equation, okay? So what we're gonna do is they're gonna ask you stuff like this, okay? And so some of you, all right, with what I like to call the math eyes, some of you will notice that this is a quadratic equation, but it's just hiding. Others will be like, what do you mean? This has a 4 in it. This is not a quadratic equation. And so what you can do now is if you stare at the middle one, okay, like if you look at this pattern, if you make the substitution u equals x squared, well, then you can figure out that u squared equals x to the 4th, okay? So then you get u squared minus 6u plus 8 equals 0. And now all of you can be like, oh yeah, that's a quadratic equation, okay? So these reducible to quadratics are just equations that after you make a simple substitution, becomes a quadratic equation, okay? So this you can solve like normal. So I'm gonna factor, okay? Yeah, minus 2 equals 0. So then you get the answers, u equals 4 and u equals 2. Okay, now, big deal. Remember that, right, the questions are always solve for x, right? When I say solve, I mean solve for x. Those aren't x's, okay? So at the very end, you need to substitute back in the x. So x squared equals 4, x squared equals 2, and you can solve both of these, right? X equals plus or minus 2, x equals plus or minus square root 2. And then you see that you get your 4 answers, okay? X equals negative 2 to square root 2, negative square root 2, okay? But yeah, this is an example of a biquadratic, which is double quadratic, okay? Expect something like this. Expect a this on your final, guaranteed, okay? Well, okay, I don't guarantee it, but probably. All right, and then another one, which I'm not gonna do because I think this video is getting a little long, but your textbook definitely likes these, okay? And so this one looks even worse than this because, right, these are fractions, okay? But if you make the substitution u equals t to the 1/3, then, right, like this is u, and this is u squared, right? Because if I square both sides, right, we know our exponent rules, so we would multiply and like, ta-da! Okay? And then you know how to solve this like normal, okay? So these are the two common versions of reducible to quadratics. Is you're gonna get like some 4th powers, 2 powers, or you're just gonna get something that's double. And then fractions, all right? But you almost always solve these by making the middle thingy, right? Here it was x squared, and here was t to the 1/3. If you make the middle one u, they will reduce to quadratics most of the time, okay? And then at the very end, you just plug back in your substitution and then you'll get your answers, okay? All right. Now, I did just remember though, back here with these roots equations, I apologize. I probably should be video editing. These root equations, you need to check your final answers. I forgot to tell you to do that, okay? Which I can't check this would be like a lot of work. I would just encourage you to use a calculator, all right, on your homework, to check, okay? But this whole like squaring both sides of the equal sign, and then here actually you're gonna cube both sides. But when you're solving root equations, you need to check the final answer because sometimes, okay, when you plug in, you might get a negative under the square root, and that's a problem, okay? That'll mean that you should not take that one as the final answer, okay? All right. I'll show you examples of that when we get to the square. There's an entire square root section too, so I'll show you good examples of that later on. But I just wanted to tell you that right now, okay? All right, now the last thing that you need to know how to solve in the equations section is absolute value equations, okay? So 2x minus 5 equal 3. All right, so absolute value equations, all right, they're actually not that hard. They're like linear equations, hopefully. All right, the big deal is that you have to split them into two cases, okay? Case one is you do nothing, right? You just get rid of the absolute value bars, okay? Case two is you get rid of the bars, but you put a minus sign in front of everything on the right-hand side, okay? Which in this case is just 3, so it's just going to be negative 3. But then you solve both. And then, like your math textbook likes to put the word or here. All right, that's fine. If you don't want to put the or, that's also fine. Okay, but if you solve them, you get 4. And then 2x, so negative 3 plus 5 is 2. 1. Okay. So your answers are 4 or 1, which that's almost always what we mean by the comma. Okay. So if you plug in 1, right, you're going to see you get 2 minus 5, which is negative 3. But then the absolute value bars get rid of the minus sign, so it works. Okay. So that's why you get 2 answers from the absolute value sign. I'm actually, okay, yeah, so we're done with this section. I'm actually going to do a bonus example right now. Okay. I would like to actually go back to this square root thing since I did forget to check my answers. Okay. So if you want some bonus square root example, please stay tuned. All right. I would like one where it doesn't work. So just let me quickly find one where it's good. Okay. Yeah, let me solve this equation. So 2x equals 1 minus 2 minus x. Okay. So this one. All right, so I'm going to solve it. 2x minus 1 equals negative 2 minus x. Okay. Now I'm going to square both sides. So square, square. This is going to be 4x plus 4x plus 1. Is that right? Minus. I was like, that feels wrong. Yeah, okay. Minus 4x plus 1. Okay, right? So guys, always, double check yourselves, right? FOIL if you need to. And this is 2 minus x. Okay, so I'm going to subtract over. So this is I'm going to add an x. So this is minus 3x. I'm going to subtract 2. So minus 1 equals 0. Does this factor? This looks like it factors. I'm going to try and factor it. So let me see. Okay, negative 1. So this definitely means plus 1 minus 1. Okay. Now the only thing is I want there to be, yeah, so I want to be 4x and x. Okay. And let me, let's do the check. Right, this is going to be x minus 4x, which equals negative 3x. So it works. Okay. All right, so then we get the answers, right? X equals, here you get negative 1/4, and here you're going to get 1, right? So those are the two answers, negative 1/4 and 1. But let's look, okay? If I plug them in, right, what happens? So I'm going to plug in 1. Okay, I'm going to do the check. So plug in 1. So you're going to get 2, right, times 1 equals 1 minus 2 minus 1. Okay, so 2 equals 1 minus 1. So 2 equals 0. Right? That's not true. So 1 is actually not an answer. Okay? And then plug in negative 1/2. I mean negative 1/4. Okay? So that gets you negative 2/4. Okay? Equals 1 minus square root 2 minus minus, so plus 1/4. Okay. And then we see this is negative 1/2. 1 minus 4, excuse me. 4. So let's do the fraction here. So 4 over, just kidding, 8/4. 8/4 plus 1/4. This is going to be 9/4. Okay. Do the square root, you're actually going to get 3/2, which, right, that is negative 1/2. So you get negative 1/2 equals negative 1/2, and it works. So here's the example of why you should check your answers when you do square roots, okay? This negative 1 didn't work, but this, well, okay, this positive 1 didn't work. This negative 1/4 is your only actual answer, okay? So big deal, all right, especially on tests, all right? Professors really like to put these kind of square root problems on tests because people, right, are in rush, so they don't want to check their answers. They're just going to be like, yeah, they both work. But most of the time, they actually don't work, right? You need to check both of them because one of them might not work. Both of them could not work. The answer could be no solution too, all right? All right, but hopefully if you stuck around for this bonus example, you've learned stuff, all right? I'll see you guys in the next section.